Any other type of problem that you would like to look at?
Algebraic functions, where we add, subtract, multiply, divide.
Yeah, so we had the function composition. Yes. So give me two functions, and we'll do whatever you want.
Gives you x plus 5.
Okay.
And x squared minus 2.
Let's make it -4 so we can factor. Good. So what do we want? We want the sum, we want the difference, we want the product, we want the ratio, we want the sum and the ratio. Excellent. Good pick. I had a wonderful professor. It was, I think it was in high school. Yes, a math professor in high school. And he would not, I don't know why, how he came up. I know why, but I'm not sure how he came up with the idea. He would never write his tests like a week ahead of time. And every time we ask questions, like you did, I would like to see this. This question was always on the test. So he said that his students were reading his mind by asking these questions. So he would always write the test, like, I don't know, 2 hours before bringing it in. But no, I don't do that. So if you ask the question that it's on the test, I'm even happier. Okay, so this is by definition f of x plus g of x. And all I have to, and of course we have to find the common domain, but they're both polynomial functions, so the common domain is all real numbers. So all I have to do now is just write x plus 5 plus x squared minus 4, and this is x squared in descending order, plus x plus 1. And this is a new function that we created by adding the two functions given to us. Now, for the ratio, that's a different story because I have to write f of x over g of x, and then I have x plus 5 over x squared minus 4. But this time the domain is the common domain minus plus or minus 2. So the common domain, if you remember, we said is always the domain of the sum, difference, and product. But it may or may not, like in this case, it may not, and it's not the same domain. So this is negative infinity to negative 2, union negative 2, 2, union 2 to infinity. So you can factor the denominator. We cannot further simplify, but we should factor it in order to determine the domain. So the domain of all the other ones, sum, difference, product, will be everything. It's always the case, always. But for the domain of the ratio, it's not the same because the denominator cannot be 0. Very good question. Thank you. Is there anything else you would like to go back to?
Can we do some of the transformations?
Yes, please. Choose any problem. Yes. Any problem you want. Any function you want.
I guess negative 2x squared. Plus 3x plus 2.
This is not a transformation.
Oh, then is it just this?
Right. So that's not a transformation. So let me make one up.
Yeah.
Can we make one that like stretches or shrinks?
Yeah. You mean horizontally? Vertically, yes. Yes, it's already in there. Okay, so what is the base function? Good. What is the first transformation in order of operations? Very good. So the base is x squared. Left 1, because it's x plus 1 squared. Great job. Second transformation is a transformation on function from 1. Very good. Stretching. Yes. Vertical stretching to x plus 1 squared. Excellent.
Can you explain why it's
Because this is x squared, and this is 2x squared.
why is it like
Because the heights, all heights get multiplied by 2. So here all heights are multiplied by 1, but here all heights are multiplied by 2.
so if it's a positive 2, it would shrink or expand?
For 1/2 in front instead of 2. So this all heights are multiplied by 1, but if all heights are multiplied by 1/2, but if this is the height of 1, all heights are multiplied by 1, but if I multiply them by 2, everything doubles. The heights are so much higher now. So this is 1 and this will be 2,
That makes sense.
right? So this is x squared, 1x squared, but 2 times x squared. This is x squared, but 1/2 times x squared,
So does that shrink?
vertically. Vertical shrinking. But this is x squared and this is 2x squared, twice x squared. That's a vertical stretching. Very good. So now, in order of operations, yes, reflect with respect to the x-axis. And number 4 is the last one, negative 2x plus 1 squared plus 4. Where does this go? Up 4. There are absolutely no secrets here, right? So this is x squared, and it goes to your left 1, then a vertical stretching, then a reflection, and then up 4. You know the vertex. You don't have to worry, you don't have to think. What is the vertex? Right. What is the range? Negative infinity to 4. We haven't even graphed it. And we know everything about it. We studied this function inside out. So now if we want to graph, we already did, but with my arms up and down. So if we want to graph, this is x squared. This is x plus 1 squared. Now this is exaggerated. This is twice x plus 1 squared. Now I reflect the pink. So this is negative 2 x plus 1 squared. And now I shift everything up 4. 1, 2, 3, 4. So this is negative 2 x plus 1 squared plus 4. Notice that I didn't pay attention where the x and y intercepts are. I didn't calculate anything, but that's a rough graph. It took us like, I don't know, 10 seconds to graph it. But now you can be asked to find the x and y intercepts algebraically. So how do I find the x-intercepts? Very good. So then I have negative 2 x plus 1 squared plus 4 equals 0. So you know this is part of chapter 1. We have to identify the type of equation, and we have to solve it correctly. What type of equation is it? Quadratic. So how do I continue? Yes. So negative 2 x plus 1 squared equals negative 4. Now I have to get rid of this. So I get x plus 1 squared equals 2. And now I have 4 methods, but this is specific for one of them. Which one? Of course, yes. So then x plus 1 equals plus or minus the square root of 2, or x equals negative 1 plus or minus the square root of 2. Those would be the x-intercepts. What about the y-intercept? The y-intercept is f of 0. So 0 plus 1 is 1. 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. 0, comma 2. So now you know that my graph, although it's quick and I pictured it perfectly, does not cross at 0, comma 2. 0, comma 2 is here, not here. So you can go back and adjust the graph. And I'm not sure about this. This is negative 1 minus the square root of 2, negative 1.4. I don't know where this is, right? So my graph is far from being perfect. But it took us, 30 seconds to graph it. And that's all I needed. I need to find the vertex. I need to see whether it's opening upward or downward. I need to find the range. And then the minor details I can go back and adjust. The correct x and y intercept and the y intercept. Very good. Anything else? I'm looking at my phone for a second. My apologies, because I'm looking at the calendar just to make sure to let you know where we are. So we have the 16th. So in October, we have 16th, which is a test. We have 21st and 23rd, 28th and 30th. And now in November, we have 4 and 6, 11 and 13, 18 and 20th, and 25. And I don't even want to talk about December, which is 2 and 4. So, okay. So I don't want to teach new material here. We still have about 10 sections left. So I'm not really sure when the next test will be, probably here. Or probably here, I'm not sure. I know we scheduled it because I had to have a tentative date, but I'm not sure. But you can cross out at least 2 more sessions, right? Because one of them will be test and the other one will be a review. So test, I can cross that out. I can cross these 2 out because I want to review fully for the final exam, start from scratch with all the tests and everything. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 meetings left. And yes. So, and I have 10 sections left. So, one, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is plenty of time. We will still have time to review, complete review for the test, complete review for the final exam. So chapter 4 has 5, bless you, has 5 sections and it has tons of applications. It's the most exciting, in my opinion, of all the chapters we've looked at. We will learn a lot of interesting applications in chapter 4. Okay, so I know we have about 15 minutes left. What would you like me to do? What I would like to do, but it's your day, I'll decide, you'll decide. I would like to start chapter 4. Of course, it's not going to be on the test on Wednesday. You can say, no, I would like to review some more, and I'll do that. Yes, anything that, so your homework has to be done between now and Wednesday. Please submit everything between now and Wednesday from this material, including 3.6. Yes, yes, so let's choose another rational function.
X plus 2 over x plus 2 over x squared plus x minus 20.
Minus 20? Very good. Okay, so here we have another rational function. We are asked to show everything, summarize everything in a table, and graph it. So my first thought would be what? When you get something like this, what will your first thought be? Say it again. Factor the denominator, very good. Sorry. Okay, and then I'll get the table going. And of course, the domain has to be our next thought. Say it again. But it's a rational function. We wish. So negative infinity, negative 5, 4, and infinity. Is that clear? It's a rational function. We wish all functions were like polynomial ones, friendly and being defined everywhere, but that's not the case. Yes, because the factor, those x plus 4, x minus 4, and x plus 5 do not go away. So they must be VAs, which means immediately I know what happens left and right. If the factor of x plus 5 doesn't go away, left and right it has to be a vertical. It has to be a vertical asymptote, and left and right I have to have infinities, but I don't know what. Till I plug in negative 5.1, negative 4.9, 3.9, and 4.1. Now I have to be careful and plug in all three factors. So do not calculate anything, just tell me the sign. Negative 5.1 plus 2, just the sign. Perfect. Negative 5.1 plus 5. Perfect. Negative 5.1 minus 4. So 3 negatives will make a negative on this side. With negative 4.9, the top. Negative 4.9 plus 5. Excellent. And negative 4.9 minus 4. I see 2 negatives. Perfect. With 3.9, the top. With 3.9, x plus 5. And with 3.9, x minus 4. Excellent. With 4.1, top. X plus 5. And 4 plus 0.1 minus 4. Good. So then, good. What type is it? Is it type 1 or type 2? So what is the horizontal asymptote then? Excellent. So y equals 0 horizontal asymptote. Let's plug in 0 in the function. Here's what I do when I plug in 0. 2 over negative 20. We're done. Is this function symmetric with a vertical asymptote at 4 and 1 at negative 5? No. But you have to write something, so I know that you didn't forget. So f of negative x does not equal f of x, and it does not equal negative f of x. Not symmetric. That's all we need. Vertical asymptotes first. 1, 2, 3, 4, 5. So x equals -5, and for 1, 2, 3, 4, x equals 4. There is no need to draw this, because it's already there, but just write y equals 0. So here's the function now. Let's check everything and see if it makes sense. From approaching 0 to -infinity. Very clear. In the middle, careful. From positive infinity, it crosses, I forgot the x-intercept. That's why it didn't make any sense. Okay, the x-intercept, please. When is this function 0? When? Exactly. I realized that something wasn't right. So -2, 0. Good. So from 0 to -infinity. From positive infinity, crossing the x-axis at -2, 0, crossing the y-axis at 0, -1/10, and going to -infinity. And on the last piece, from positive infinity to 0. One more time. From 0 to -infinity. From positive infinity, crossing at -2, 0, crossing the y-axis and going to -infinity. And on the other side, from positive infinity to 0. It all makes sense now. I have to plot 2, -2, 0, and I have to plot this point whatever. So from 0 to -infinity, from positive infinity crossing, going to -infinity, and from positive infinity to 0, and that's our function x plus 2 over x squared plus x minus 20. You can check with the graphing calculator. There is a piece here that I cannot talk about. I can tell you about it, but I can show it to you because we don't have tools. We need calculus for this. So here's what happens with the middle part. But again, you don't need to remember this. So the function does something like this. From opening up, all of a sudden it starts opening down. That point we cannot determine. So I don't know if the function does this and changes, we say changes concavity here. It's possible that it changes concavity here. We don't know. It's not, we don't have enough information, and the calculator will not give us this. But in calculus, that's what I do with my students. So in y equals, clear, and the numerator was x plus 2. That point is called the point of inflection. You don't need to remember that. So x squared plus x minus 20. And I don't know, I'm going to use the standard for a moment. So here it comes. You know the calculator is lying. The function doesn't stop here. It goes all the way to -infinity. Function doesn't stop here, it goes all the way to positive infinity. So it's hard to read. I'm assuming that this is going to be the point of inflection right here, but we don't need that. So we know that the function doesn't touch the x-axis. It's a lie. So be careful. Do not just copy. You know, if I see a copy like this, what you see right now in the viewing window, you copied on paper, then I know that particular student doesn't understand this. Does not know what is going on. Yes? Questions? Okay. So you don't have to worry about that. I'm not sure, again, if it turns here or it may somewhere here, it changes concavity from opening upward to opening downward. But there is no need. We can determine that. I have to find derivatives and the second derivative, not just the first, to determine that point. So, good. Next question. Anything else? Is there anything else that you would like to look at? Any other type of problem? Anything else that you would like to review? We still have 5 minutes. Which one?
Quadratic function.
Yes?
X minus h. A x minus h squared plus b.
Today's the 14th, correct? Okay. Yes, I'm ready.
-3 parentheses x plus 2 squared minus 5.
What are we trying to do?
Or graph that again.
Oh, through all the steps? Very good. So number 1 is the shape. So since the leading coefficient is negative, so it has to have a maximum. And number 2, the vertex is -2 comma -5. There's no difficulty here. There is no need to calculate anything. Now, let's think about the x-intercepts. Very good example. So let's think. So it has a maximum. What is the maximum value? Correct. So then the range is till. I will not waste my time with this. They don't exist. None. Because the range is -∞, -5. And it has a maximum. But the y-intercept has to be determined. That will always exist. So let's do this together. 0 plus 2. 2 squared. 4. 4 times -3. And -12 minus 5 is -15. So y equals -15 when x is 0. 6 and 7 are just words. Axis of symmetry, it's x equals -2. There's no even parenthesis. I don't know why I put in parentheses. And the max, you already told me, is -5. Very nice.
Wait, is the y-intercept -15 or -17?
I can't get away with anything. Sorry, I said -17, but I wrote -15. Thank you. My apologies. So -2, 1, 2, 3, 4, 5. So this is x equals -2. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, of course, 5. So here it is. Try to make it as symmetric as possible. So this is f of x, -3, x plus 2 squared minus 5. Very good example, thank you.
You put that -15 again.
I did? Of course, yeah. I'm sorry. Okay, I'm going to say this is -17. Sorry. I got stuck on -15, so I don't know how and why. Thank you. Sorry about that. It wasn't intentional. Moving forward, -15 is the same with -17. Say it again. Is it? Oh, the function? The function is this.
Total test and video on what's out, like,
Yes,
what we're trying to-
yes, I will. And if you have any questions, I'm here so you can ask if you get into any difficulty trying to take attendance. Please review the notes and finish up your homework. It will definitely help you if you do. So remember, we are striving for 100%.
For the circles, do you think that guess whenever you're completing the square in the test?
I made it extra credit. Always hear Medicaid is not